Hey everybody, Mr. Rubo here. We are continuing with topic 3.6, sinusoidal function transformations. And we've talked about, in the previous video, vertical translations, vertical dilations, and horizontal dilations. So, right, we had amplitude, midline change, and period change. We also talked a little bit with reflections. There is one last one, which is called a phase shift. And so a phase shift is just another way of saying a horizontal translation. So the moving left or right of a sinusoidal function. Now it does have a special name because when you shift it, it could end up being the exact same graph with a shift because of the fact that it keeps repeating itself. If you shift it over the right amount, it'll look actually exactly as you started because of the periodic nature of it. So the way we see this is kind of similar to how we see everything else. It's inside of the function written as addition or subtraction of x. So in this case, g of x is written as sine of x plus c. It is the phase shift of the graph of f of x, which is just sine of x here, by negative c units. Okay. And you have the same thing that'll work for cosine. Okay. So yeah, you had a plus pi, you'd be moving to the left pi. If you have a minus pi, you're moving to the right pi units. Okay. So yeah, we get to a couple examples here, or at least one example. So this first example, we have tells us it's a trig function, which the following expressions could be for g of x. So with this kind of thing, now we can't just assume because of where it's starting that it could be. So you look at this and you're like, oh, it's a negative cosine. Well, if you look at the negative cosine one, the answer choice here, it also has a shift to the right by pi, which means that where it would actually start is here, the negative 3. So it does not match up with this one. So with this kind of equation or this kind of problem, because of the fact that you can write these equations in a lot of different ways, you do kind of have to check each one. So let's go ahead and we'll go through all the options. So A is 3 cosine of x minus 1. Well, minus 1, we'll kind of do our midline there because it's going to be the same for all of them, right? They'll have the same midline. So that's good. Okay. And then 3 amplitude. So I'm going to do like a max line and a midline, which again, a good multiple choice question won't give that away because now we have all of them at 3. So let's see if I look at this first one, 3 cosine x minus 1. Well, taking into consider the shifts, cosine would be up here is where we'd start. And I don't even really have to graph the rest of it, but here's kind of all those key points. And you can kind of see they're all in the wrong spot, right? They're all opposite other than the ones at the midline, but they have to be exact. So that one's out. The next one I kind of already talked about, right? So normally, if you had negative 3 cosine of x minus 1 without the minus pi, you would be starting here and it would be working. But this is telling us to move to the right by pi. Well, pi is the second tick mark, so that means I'm starting here and then going and doing the cosine pattern. Well, guess what? These two answers, A and B, are actually the exact same equation. Exact same graph, I should say. They're different equations graphically, but, algebraically, they look different, but they end up actually giving you the exact same graph. All right, so now the last two are sines, which you're like, oh, this wouldn't be a sine, but obviously it has to be because that's our only options left. So if I go ahead and do C here, we have sine, so we would start in the center at the midline, but now we're going to the left by pi halves. So that means I would actually start over here at the first tick mark, and it's a positive 3, which then means I would go up 3 to my next point, which means it's up here, and then look at that, ends up that this guy is also the same. So all 3 of these choices are the same graph. That's what ends up with these phase shifts, is it makes it so we can name the same graph an infinite amount of ways. In this case, it tells us that, hey, these are all the wrong answers, which then hopefully means that this one is right, but let's just double check. So we're going to the right by 3 pi over 2. 3 pi over 2 is this tick mark right here. It's signed, so starts in the middle. Good so far. And then it's negative, so it would go down first and then back up. So that is indeed the correct graph. So yeah, if you're given a multiple choice question like this, just go through all the options and check the points. And if they're not lining up, you know it's not the answer. And a lot of times you will have something like this where 3 of the answer choices are actually very similar, if not the same graphs. And then the actual answer will be the one that fits. All right. So yeah, that's it for today's video. Thanks for watching. Have a good day.